So, I know a few of my viewers watch Dave Jones' channel, EEV blog, and a few of you watch Techmoan's channel as well. So, they've both recently done video editing type consoles or audio type consoles, so I figured I would get around to doing my one. Unfortunately, this one does have no tone sandy button, but well, you call those editing consoles? That's an editing console. So you're freehand for a bit because this thing is just enormous. This system is ex-BBC again. We did a quick preview on this quite some time ago. We didn't get around to doing this. There are more buttons on here than there are on the bridge of the Enterprise. We've got a problem with that, but that appears to be cable related. So this system consists of, well, the console consists of 3 parts. The entire system consists of what I have of 5 parts, one of which Dave Jones has torn down on the EV blog, which I'll link in, and we will be tearing that down as well. We've managed to find a little bit more information than when he did the teardown. It was a few years ago. We've also got some other bits that he didn't have, so we'll go through those as well. And I want to take my time with these because it's such a beautifully built bit of kit, and we'll go through this one by one. So we have a display here, which this has 2 power supplies in it. It's adamant that it must have both, and it will not let me forget the fact that I don't have both. The lovely amber plasma display there. This is a separate unit, which is designed to sit roughly where it is. Then we have the desk itself, which I'll go over in a second, and then we have another unit which just extend the capabilities a bit more. 25 minutes. We got this, excuse me. This one is having a funny 5 minutes. We did get this with some cables. Now, I tried to use the cable that's now on the back of this with the display, and the display worked, but it wasn't right. And looking at this, there's obviously some funny wiring going on the cable. So we'll come back to this in a second. I'll swap the cables over once I've disconnected the display, and you can see what it looks like. The actual system itself is not really showing much at the moment. But there is cable. There is no end of buttons and switches and things. I mean, if you're a 5-year-old child, this is absolutely amazing. I mean, from recycling the parts on this alone, there is just so much you could do. So we'll have a quick look at this display. It is going to be flickery, unfortunately. There isn't really much we can do here because we've got this error that's stuck up here. But it's a lovely non-burnt display. There's not really much going on frame memory and things like that. Part of this is going to be because we don't have our what do they call them? DME, digital multi-effects. So we've got frame memory pages, which I assume allows us to store individual frames. Then we've got all sorts of wipes, but handled by the DME. We have these wipes, again not sure what these are. We appear to have locally controlled ones, which I'm guessing will probably use the DME again, or DSK for desk maybe, I don't know. And then we've got keyframe stuff, we've got disk operations, there's a floppy drive there, which does work. I don't think that really is much on here. Oh, there is. Keymem and charmem. Can we select things? Or do we have to grab the lot? Nothing there. I'm curious to know what that charmem is, but did we do all load? Yep. Back. Do I want to load? Yes. I have no idea what I'm doing here. I'm assuming this is going to fail because there are bits of the system not present. Hopefully that didn't just cut you off. Communication error, so yeah, there's issues with the DME. Chroma key. Yeah. So we appear to have 3 effects engine support here. DME1, DME2, DME3. System and utility. I doubt there's anything in here. Setup for the DMEs which aren't there. Lighting effects. Broken glass. There's a fair few non-linear effects here, but I don't think we'll be able to use any of these. I don't have any digital video. I forgot what they call this now. I don't have any SDI stuff, so I can't test any of this. So yeah. So it does appear to work, but unfortunately it is more or less useless. It's very modular, as we'll see when we get inside. So let's just go and swap these connectors around so you can see that running properly, and then what I'll do is say I'll do a video on that and a video on that separately. I have plans for that if I can work out how to talk to the screen. I'll show you this running, and then we'll pop the hood on this thing. So we've got our panel working, we've got a little bit more life now, so let's got those lovely dot matrix displays in there. We've got slightly more life down here. So I believe these are mostly inputs. There were labels on these, but they have unfortunately long gone. I can bring more up. Weather there, maybe. So, yeah, I mean, I suspect there is a fault on this, or there's a configuration issue or something, because I can set these up without any problems at all, but the others don't stick. So, but there we go. I'm going to pop the hood on this and we'll have a look inside. So unfortunately this thing is absolutely enormous, and that I'm going to struggle to frame this, but here's a quick look at the back of everything. We'll go into each part. I don't really want to tear this down too much, but we'll have a good look. We have 2 absolutely enormous redundant power supplies under here. Not sure what voltage we've got coming there, but it appears that we've got power coming up to run most of everything over here. A separate run for these panels. Now the panels do appear to be completely modular. I will try and pop one out. I've already had a look briefly at service manual. Already had a look briefly at service manual information on these, and these daisy chains appear to be serial. So everything in here is done via a serial bus, probably quite similar from SPI, but what I can see, and everything is daisy chained. So I think we've got one row there, one row there, one row there, and one row there, and they are all daisy chained. We have a back panel board down there. Hopefully this lighting is working for you. And then we have this enormous motherboard up here with a lot of logic on it. And right here we have, for the 68,000 fans, a 68, come on focus, you can do it, 68030. And unfortunately, one of those. Anyone that's done work on old computers will be very familiar with those things. Come on, focus. So that could be some of our problems with it playing up. Although this was in service until very recently with BBC, so I wouldn't expect there to be any issues. Let's just get a close up on those two for you. There is a lot of programmable logic in here. More there, more there. They do seem to have some explanation of what they do, and ROMs, so we'll have a good poke around this. Again, I say a lot of this is serial, so a lot of this is going to be focused around all of this. Unfortunately, there's not a lot really to look at, so I'm going to put you in a tripod and we'll have a poke around. So I'm quickly just going to zip out what I think is going to be the easiest one of these to get out. So we've got some lovely cable management in here. As I say, it looks like we've got a loop in, loop out type arrangement here. That connector comes out. That looks to be power. I'm having to work round you now, which doesn't make this easier. There is a latch on that. There we go. And I think we are held in on four corners. Sony have on here, as they do quite frequently with their equipment. Now let's just let that drop into there. Sony have, as they quite frequently do on their equipment, appear to have labelled the screws we need to undo. And there we go, we think we've got that out. We do. Okay, I don't want to take the motherboard out, so let's have a quick poke around down here. Actually, I think we will try and take this processor board out because it'd be nice to have a good close look at it. There's just no way I can really get you in this way. It does look like it's put together in such a way that it's fairly idiot proof, so we'll give it a go. All of these connectors are obviously going to remain roughly where they should be. That's the one that we've just disconnected from our keyboard module. We've got these big ribbons here which go down onto that. I was hoping the CPU board would come out as a module. I can see that they've designed it to, but these ribbons may actually stop that from happening. Got a little FPC connector there. How does this one work? They all work differently. We're not going up. We're just pulling out on that. There we go. Right. We've got locks on. Oh, there we go. Pull the locks in, drop them down. So we know we've got one there, which looks like it needs to be loosened rather than removed. I'm guessing there will be one on the other side. Can't really do this without getting in the way. Let's just put that back in because I don't actually want those out. We have two in the top. Professional gear like this will be designed to be very easy to service and work on. If you think this was running a complete studio at BBC Cardiff, you can't afford to have a complete studio down for that long. Let's take out one of those display boards as well. Let's go for, what can you see? Let's just pop out a display board. We've got two power connectors there, so the power supplies look like they are loop in, loop out as well. I'm trying not to bash my microphone because I noticed I'd done that quite a bit in the previous video. Right, I think we're all clear. Again, we've got labelled screws, thank you Sony. It makes sense for there to be a few more on this one. Yes, I realise that this screwdriver is a bit sledgehammer to crack a nut. I want to keep this together in working condition, but I'm not actually sure why. That's probably going to drop the second we get that out. You know, there is a lot of salvageable parts in here, a lot of parts that are, if salvaged and removed from these boards, are actually reasonably valuable. Those dot matrix displays are a really good example. Are we just going to pull out here? There we go. go. Oh, that's lovely. Look at that. And they're lovely display. Lovely keys on these. Right, let's put that to one side. Now I'm going to pause here and take this off of the bench. What I will do quickly is take you out of the stand. And you can see the modular design here. So we have a processor cable that came in here. That loops through to that one, that loops through to that one, and from there we're looping down to that baseboard. And same here, we've got with data coming in, data leaving, power leaving, and our power was coming in just here. It'd be easier if I wasn't zoomed quite so far in. So there, and I suspect there is a way to remove these as well. And you can see there that they're all designed to just slot together. Right, I'm going to pause for a second and I think we'll probably go overhead again. Just thought I'd bring you back again and just look at the design on some of this. So this is a gas strut to hold this lid in this upright service position. And it's consistent with what I've seen on the other modules. It really is really well built. I suspect, looking at that, got individual power switches there. But it looks, there is some provision for being able to eject the power supplies. I suspect that screw there's got to come out, but I'm not going to mess with that now. Right, honestly, I'm going to put you back on the bench now. So here we have our victims. So we'll poke around each one individually. I'm going to leave the processor board till last. So let's have a look at the keypad module first. I suspect they're all both going to be fairly similar, but we can have a look. So let's take this out of the way. Also notice, other than the odd dust bunny in the bottom of that, how clean it was. He says, looking at the mess left behind. So let's have that there. Bring you down. Make sure I can see where you are. So I'm not expecting there to be much in this. I know that this is serial based. There is an awful lot of programmable logic FPGAs and CPLDs on that board to handle the serial. So I have my suspicions how all of this is managed and how it all works. They're probably going to appear as a series of memory map registers. And given that the 68000 doesn't have I/O ranges like the Intels do, these keys and everything else probably appear as registers that can be read and written by the processor. Now the first thing that I can see here is looking at the back. There's very little on here in terms of processing. We have a very large number of transistors, which is going to be driving the LEDs in here. Let's flip this over. Okay, this isn't quite so clean. But we have, the only logic we appear to have is at the bottom here. What I suspect is 7.4 series logic. There's some more up here actually. And there it's fairly standard other than that. The keys are very, very good quality. I was expecting Alps, but they're not. These have got AGAS written on them. I don't see any identifiers on these, but they have, I don't know if you can hear that, a lovely feel to them, even those ones. So the display modules will probably be fairly standard ones. Let's just pop those off. Again, the build quality on this is absolutely excellent. I can see some of those dodgy aluminium electrolytics though. Can we get that off? Yes we can. Let's just rescue those screws. Oh, this is getting quite manky now. a screw in there. Okay, how have I managed to lose a screw into there? There it is. Right, so these are little dot matrix displays. Focus. They're really lovely little things, and I've never seen them in anything other than red before. They are HDSP 2003 LPs made by Osram. I was expecting HP, and I will pop a link up there, possibly. I don't think I can do things. They are HDSP 2003 LP. They are Osram display units. I will pop, look, can't do it from this angle. I will pop a link down there for these. Looking at this board, we have a couple of transistors on here. No, they're diodes. So I suspect there's diode steering going for the select logic for these, and then everything I'm guessing would be common. So I mean, that in its own is quite a nice, useful little bit of kit. I believe Fran over at FranLab has done something on these. I'm not sure. If I can find it, I'll link it in. But it's a lovely little display, and they're incredibly useful. And that's part of the problem I've got. If I tear it down and liberate all of those, and I mean, you've got 3 there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 there. So we've got how many rows of those? 4. So there's 80, before we even count all the little ones, there's 80 of them in there. And they've got good resale value. So 80 of those is probably going to be worth more than I paid for the whole thing. So we've got some logic there. I'm expecting this to be fairly straightforward 7.4 series logic. I'm not even expecting custom Sony chips. So we have a 7.4 HC595 there. I can't quite remember what a 7.4 HC595 is. I have a feeling it's a multiplexer of some kind. Let's have a look. I will just, I don't know if you'll see that on the phone, but there you go. That's a fairly standard shift register. So that's one of what's driving some of our outputs from the serial stream. So I'm guessing there's going to be more of those because we've only got 8 outputs on there, which isn't enough. 7.4 LSO4, I believe. They're inverters. I'm not sure I believe that. Quite often with these small SMD chips, they omit the 7.4 part of the number. And given that we've got identical HP165, what I will do is I will have a look at this, get an idea of how it works. I want to know how these work because, again, this is a really nice keyboard. This alone is quite useful, and it might be fun to mess around with them and see what we can do with them. So I will trace out the circuit diagram of this, or trace out a block of it, so we can get an idea how to talk to it, and maybe we'll see what we can do, because obviously we need to be able to write the LEDs on here and write data to the display, but we need to be able to read data as well. Now, I don't think, given that we have what appears to be only one shift register there, that is enough to drive this. Shall we just have a quick look and see what the other ones are? I doubt you're that interested, but we'll have a look. So we've got a 7.4, we'll say it's an LS just because. That's a 166. That's a shift register as well, okay. So we've got 1, 2, 3, 164, 176. So this is all just jelly bean logic. 164 is another shift register over here. So yeah, I will have a look at just getting an idea how all this goes and works, and if I can do it, I will pop a circuit diagram up in 3, 2, 1. Meanwhile, back at the ranch. So have a look at this again. Not going to take the back off because I don't think, as with the others, there is not really anything on the back. So again, all our logic is on this bottom edge here, and that will be the same again. And we've got a dip switch down here for something. Oh, there we go. So I don't know if you can see that. That dip switch allows us to select which panel we are. So these are obviously addressed in some manner, or again, because we're just spitting out serial to parallel, we could be just looking for certain positions in that bit stream. So for example, if we had, just for example, because that's not what we're doing here, we've got spare buttons here, not used buttons. Those certainly show through, but those don't. You can see the LEDs underneath, possibly. So yeah, so let's say we've got 4 of these panels, and we've got a 32-bit bit stream, and each one of these wants 8 bits. Then all we need to do is listen for a reset that indicates that our bit stream is starting again, and count the clock pulses, and say for the second bank we need to count 8 clock pulses, and then the next 8 clock pulses are our data. This will be doing something similar, I would imagine. However, obviously there's a lot more than just 32 bits here, so there's going to be massive shift registers in the motherboard, in that control board. We have large LEDs there. I think that's all they are. They are just some nice big large LEDs, and to be fair, I don't see what they were doing. So yes, there is an illuminated strip, but I couldn't see what those were up to and what function they did. So again, quick look on the back. I'm guessing we have, which way was this in? So that was in that way. So that will be serial in, serial out over here, serial out up there, and then we've got a power in and a power out. So it's a nice modular way of doing things. They're not that particularly secure. It's a nice modular way of doing things, and if you are pumping out large amounts of serial data, there's all sorts of concerns RF wise, but if you're sending out big data streams like that, then, and you've got a way of loading the shift registers quickly and easy, then yeah, it's a sensible way of doing it. It keeps down on the wiring. I suspect, having looked at what the display panel is doing, and that's where I've looked at the diagram, that what's actually happening is we have an input and an output bus.